we'll start there. So if you have homeworks that you need to take out to look at, to know what you want to ask questions about or whatnot, go ahead and do that. Or if you have a tablet you need to log into to look at where you wrote down your homework at. I know some of you guys have been doing it in your OneNote, which is fantastic. That's perfectly fine. But if you need to look at that to be able to ask questions, certainly go ahead and do that. Walter, what's up, bud?
You got mine, right?
I haven't checked anything yet.
Well, it's just been in copy and paste it in QuickBooks, right?
Nope. So you're in your notebook. You need to be in this notebook. So you'll copy and paste it from wherever you've got it here. And you'll want to put it in your section there.
Thank you.
Yep. Okay. So, who wants to start? Does anybody have any that we need to talk about here? Joe. Number 9. Sure. Do that. Save me some clicking back and forth. Okay, so the absolute value of 2/3 x minus 6 is equal to 12. So first thing we'd want to do is to get the absolute value part by itself. It's already done, right? So from here, we can just split this into two equations. The first equation, we just drop the absolute values. The second equation, we drop the absolute values and we negate the right-hand side. And then we can just solve like we'd normally. So we'll add 6 to both sides. And then we can divide by 2/3, but rather than thinking about this as a division problem, what's probably easier is to think about it as a multiplication of a reciprocal. Right, dividing by a fraction, maybe not as easy as just thinking about multiplying by the reciprocal. So to multiply two fractions, remember we just multiply straight across. But what might be easier in this case is to reduce before we multiply, because I noticed that 2 reduces with the 18. So I'm really left with just 3 times 9, or 27. And then similarly over here, again, I'm going to think about this as 6/1. And I'm going to reduce before I multiply. So I'm really left with -3 times 3, or -9. And then we're just left to check these. If you'll take my word for it, I think they both should work. Does that feel okay there, Joe? Yeah, you're welcome. Paradise. 14. So that's 9 minus 2x equals 10 plus 3x. Okay. So again, the first step would be to get the absolute value part by itself. That's already been done for us here, though. So we'll just start by splitting it into two equations. So the first equation we get just by dropping the absolute value symbols. The second equation, we drop the absolute value symbols and we negate the right-hand side. Probably the place that's easiest to make our mistake here is just negating the 10. But when we have a negative sign applied to an entire quantity like that, we know the negative has to distribute. Is that okay, Paradise? Okay. And now from here we can just solve as we would normally. So let's subtract 10 from both sides. And then I can add 2x to both sides. And then divide both sides by 5. And similarly over here, let's add 3x to both sides, and then subtract 9 from both sides. And we're left with this piece, or this part. And if memory serves, this one is definitely extraneous. And I think the other one works, though. Let's just check that with our calculator real quick. So all I'm going to do to check this on my calculator is I'm going to just plug in to the left-hand side and then to the right-hand side separately and see if I get the same value each time. So to get the absolute value symbols, I press the math button and I go over to the number menu and I'm going to select ABS. So 9 minus 2 times negative 19. So that gives me 47. And then I have 10 plus 3 times negative 19. And that gives me negative 47. So yes, the negative 19 didn't work. I discarded that correctly, I remembered. So now I'll go and check the negative 1/5. So again, we'll do the absolute value, 9 minus 2 times. And then to get that fraction in there, I'm going to do alpha y equals. That's a shortcut to the fractions menu. And more often than not, the option we're going to want is the first one, the numerator over denominator one. So I'll just do negative 1 over 5. And that gives me 47/5. And then 10 plus 3 times, and then alpha y equals n over d. Negative 1 over 5, and that also gives me 47 over 5. So this one I know works. Does that feel okay there, Paradise? Okay. Who else wants to talk about one of these? Okay, that's fine. Overall, hopefully this went fairly well. It should have felt a bit more familiar than what we had been doing previously, as this should feel a lot more like the algebra that you remembered from Algebra 1 or whatever, right? Where we're solving and doing more familiar algebraic skills. Today, what we're going to start talking about is graphing. So to do this, what we're going to do is we're going to recall a couple of things from last chapter. So from last chapter, we remember that for a function y equals f of x, we can write any transformation of f of x as g of x equals a times f of 1 over b x minus h plus k. So this was one of the last topics we talked about last chapter. So for an absolute value function, the f of x that we're talking about is just the simplest absolute value function we could write, which would just be the absolute value of x. That means that our g of x then would be a times the absolute value of 1 over b x minus h plus k. Is everybody okay what we did there? We designated our f of x as the absolute value of x. So in turn, then, our transformation became specific to the absolute value function. Right? Okay. Well, we can actually make that g of x statement a little bit simpler. So recall from last time we said that the absolute value of x times y is equal to the absolute value of x times the absolute value of y. You guys remember that? So in the case of g of x, I notice that I have multiplication going on inside my absolute value right there, between the 1 over b and the x minus h. So using that same rule, I can do that. Now the 1 over b is just a number, right? So when we take the absolute value of the number, we just get the positive result for it, which means that it can just kind of get absorbed up into this a over b, or into the a, I should say. So what we conclude here is any transformation that can be done by the b coefficient can also be done by the a coefficient This means we only need to represent our transformation as g of x equals a times the absolute value of x minus h plus k. Is that the b doesn't really matter for us. Anything that b can do, we can actually do with the a value. So that makes life a little bit simpler for us. Okay. There's one more piece from last chapter that we need to talk about and kind of put into the mix, and then we'll kind of sort through doing this with a specific example, okay? So last chapter, we talked about how we can transform any points from our y equals f of x into a point in our transformation using this map. So when we're talking about y equals f of x and g of x equals a times the absolute value of x minus h plus k, the map we'll use is almost the same thing, but here we can just forget about the b value, since we established just a moment ago that our b value doesn't really matter. So this is just some groundwork to justify the process that we're going to use to graph. This is not anything that you would have to repeat. Okay? This is just me kind of justifying the process that I'm going to use to graph these absolute value functions using the language that we developed in the previous chapter. Pretty much from this point forward, this is going to be the same way that we're going to develop our procedure to graph any function that we talk about in this course. So we're always going to be going back to this idea of a transformation and always going back to this map from the original points to our transform points for every function group that we talk about this year. So let's finally do an example here. Ooh, yeah, that's fine. So let's say, before we can actually do an example of a transformation, we need to look at this original version, right? Y equals the absolute value of x. So to graph this, all I'm going to do is make myself a little XY table. And the x values I'm going to use are -1, 0, and +1. When I plug -1 in for x and take the absolute value, I get a +1. When I plug 0 in for x and take the absolute value, I still get 0. And when I plug +1 in for x and take the absolute value, I still get 1. So if I were to draw the graph for this, I have the point -1, 1, 0, 0, and 1, 1. So my graph is going to kind of look like this V shape. Is everybody okay here? So this V shape has this special feature here. The tip of our V shape is called the vertex. And then if we think about the domain and range for this function, notice that here we have a left arrow, which is like the point -infinity, +infinity. And we have a right arrow, which is like the point +infinity, +infinity. So if I think about the domain, I'm going to pick the point furthest to the left and look at its x-coordinate. And then find the point furthest to the right and look at its x-coordinate. And since those 2 points are connected, the domain is just going to be the x-coordinate from the left point, comma, the x-coordinate from the right point. Is everybody okay there? If you guys are having trouble seeing, you can always turn the lights out. Okay, so again, no problem with that if it ever gets hard to see. I know with the lights on, I'm always hesitant on first hour about whether it's going to be too dark in the room or whatever, so usually the lights start on, but if it's hard to see, stand up and turn them off. You have an open invitation to do that whenever necessary. Okay, now let's do the range. So the range, we're going to find the lowest point, which is here at 0, 0. And the highest point, well, there's really two of them. Either of these arrows is the highest point. And then we're going to go from y coordinate to y coordinate. And the one thing we have to be careful about now, since one of the y coordinates isn't an infinity, it might need a bracket or it might need a parenthesis, right? The infinities we know are always parentheses. But the 0 there, should that get a bracket or a parenthesis? It should be a bracket. Very good. Why does it get a bracket? Because we have actually a point on our graph that uses that y coordinate. Right? 0, 0 is actually a point on our graph. If that was, say, like an open point instead of a filled-in point, then we would use a parenthesis. So here, the big takeaway is going to be, these are the 3 points that we're going to transform every time we graph an absolute value function. Okay, so let's graph one of these now. So the first thing I'm going to want to do is identify the values for A, H, and K. And I'm going to do that by using this form to identify those values. So what is the value for A got to be? -2. Just using our eyes, we can pick that out to be -2. Everybody okay there? Here's the tricky one. What's H gotta be? -1 is correct. Notice the H in the original equation is negative. So the sign on H is going to be the opposite of whatever it appears in our problem. So it looks like it's +1, but really we know it should be the opposite. It should be -1. And then what's our value for K? +3. Everybody good there? Okay. So now I'm going to write my map. So I remember that the form for my map that we established earlier is xy goes to x plus h, comma, ay minus k. So I have values for h, a, and k, so I'm just going to plug those in. Everybody still good there? And now I'm just going to transform those 3 points that we found a moment ago. It's always going to be these same 3 points every time we graph an absolute value function. So just taking those same 3 points we established a moment ago, and I'm going to plug those in. I don't know why I didn't put the 3 there. So all I did there to find those new points is I plugged in the x and y's into my map and then evaluated, right? I just did it in my head. Is that okay with everybody? Since it was whole number arithmetic, I just did it in my head. If you have to write it down or want to write it down or use your calculator or anything like that, that's perfectly reasonable. Okay? So far, so good? Okay. So now I can plot those 3 points. So I have -2, +1, -1, 3, and 0, 1. So here's my new graph. Is everybody okay with that? So this should feel quite familiar, right? It was the same way that we graphed the transformation last chapter, which is why one of the reasons I think chapter 1 is kind of a hard one, because you see all these new kind of skills, and then typically the next few chapters get a little bit easier because we just take those same skills that we built up in chapter 1 and we use them in specific contexts. So it's often doesn't feel that much different. It feels kind of the same, which is nice, right? Like we'd like to find one way of doing something that works kind of over and over and over again, and that's what we're doing. So the graphing should kind of continue to get easier and easier and easier as we go, because it's the same sort of graphing over and over and over again, or the same approach over and over and over again. Is that okay with you guys? Okay, we should talk about the domain and range for this new function. So to do the domain, I'm going to find the furthest left point, which is this point. Since it's a left arrow, it's -infinity, and since it's pointing down, it would be -infinity. And the furthest right point here, because it's on the right side, it's +infinity. Because it's pointing down, that makes its y-coordinate -infinity. And since we're connected in between, my domain is just going to be the left x-coordinate to the right x-coordinate. Now, question for you guys. If my graph for an absolute value always kind of looks like this V, is my domain going to be ever anything other than -infinity to +infinity? No. The domain for an absolute value function will always be all real numbers. That's nice. The range now, we're going to identify the lowest point, which is one of these two arrows, and the highest point, which is at the vertex, that's the point -1, 3. So for the range, I'm going to go from the lowest y-coordinate to the highest y-coordinate. So that's -infinity to +3. Then again, since 3 is not an infinity, I need to make sure I'm checking to decide whether I should use a parenthesis or a bracket. Do I have a point who uses the y-coordinate of 3? Yes, right? I have it right there. So I know I should be using a bracket there. Now, is there a way that we can think about the range so that we don't have to go through this process of identifying the highest and lowest points? Because it seems like in some way the range is always going to be involving this vertex, right? We've done 2 of these with the range, and either the highest point or the lowest point was always the vertex. You guys notice that? So in general, the domain is always this. The range, though, it's going to depend on whether I have a wedge shape or a V shape. So if the A coordinate or the A coefficient is positive, we're going to have a wedge. That means the lowest point is going to be the vertex, which is going to be K. And if that A coordinate is negative, then we're going to have a wedge shape. The highest point would be the vertex. So the range would start at negative infinity and go up to the y coordinate from the vertex, which would be K. So either way of computing the domain is fine. You can look at the graph like we've done in the previous chapter and kind of reason things out. Or you can identify that it's an absolute value graph and use these rules that we've established to figure out the domain and range. This is probably a little bit quicker, and I think less likely to make a mistake on, but you have to remember the rules. So whatever works for you, I am perfectly fine with. Should we do one more of these and then move on? Sound good? Okay. Okay. So I'm not going to write down as many of like the intermediate things that we wrote down last time, because the first time we did it, I was trying to be really clear and showing you where things were coming from. This time, we're just going to try to write down kind of what I would consider the minimum amount of work that you should show on a problem like this, just to make things a little bit neater. Especially since you've had one example where we were really thorough with what we were doing. So let's identify the values for A, H, and K. What's my value for A? 1/2. What's my value for H? +3. And what's my value for K? 4. Then I'm going to write my transformation map, but I'm just going to write the version where I filled in the numbers. Everybody's okay there? Again, that's x plus h, ay plus k, the same formula that we used in the previous one. And now I'm going to take my 3 points from my absolute value. Every time I'm graphing an absolute value, I'm using these same 3 points over and over and over again. Is everybody good there? Okay. So then I'll just draw my graph. 1, 2, 3, 4. 1, 2, 3, 4, 5. And I have 2 and 4.5. 3 and 4. And then 4 and 4.5. So there's my graph. My domain then, since it's an absolute value function, the domain is always negative infinity to positive infinity. And the range then depends on the A and the K. Here, since A is positive, I know I'm going to be starting with my K value and going to positive infinity. If the A value is negative, we'd start with negative infinity and go up to K. Yes?
This is the minimum where you want us to do from.
A graphing problem? Yeah, this would be a sufficient amount of work. Yeah, you can always show more. No problem doing that. But this is kind of the minimum that allows me to dole out like a reasonable amount of partial credit if you make a mistake somewhere. So if you show me what you're using, or like what your values A, H, and K were, the map that you used, the 3 points you started with and the 3 points you get, and then your picture in the domain and range, that would be sufficient. Is everybody okay there? Okay. The next topic, another graphing topic. So the next topic is graphing absolute value inequalities. And I wrote in parentheses here in 2 variables, not to be confused with when we graphed the inequalities when we did the solving, where we just put them on the number line. So this process is almost identical to graphing an absolute value function. There's 2 small things at the end that we'll talk about that we need to do a little bit differently. But I'm just going to dive right into an example because most of the work is identical to what we've just done. Everybody okay with that? So let's say we want to graph y is less than, I'll put negative absolute value x plus 2 plus 1. Okay, so at the start, we're just going to pretend that we just have the function. We're just going to pretend that there's an equal sign there instead of a less than symbol, and start this problem as if it were just like the previous ones. So we'll start by identifying our values for A, H, and K. Our value for A here is -1, very good. And our value for H is -2, and the value for K is +1. And then I'll set up my transformation map. And fill in or perform that transformation on my 3 key points. Again, those points are the same for all absolute value functions. Then we'll draw or plot these 3 points, but then we're going to pause. Okay? So here are the 2 differences for an inequality when we're graphing an inequality rather than an equation. The first thing is is that for a less than or a greater than, we're going to draw a dashed line instead of a solid line. And then similarly for the or equal to versions, we're going to use a solid line. Our problem, we had a less than symbol, right? So when we draw our graph, we're going to draw it with a dashed line. The second thing we have to remember to do for an inequality is do some shading. So for a less than or or equal to, we're going to shade below. And for a greater than or equal to, we're going to shade above. So the area that's below my line is like that part right in there. Is everybody okay there? So we just have these two little extra things that we have to do. But otherwise, it's the same process that we just used, right? So in fact, the hardest part of the process is probably the exact same. The last part here is just, you have to remember which one gets, which symbol do I use solid for, and which one do I use dash for, and which symbol do I shade above, and which one do I shade below. Let's do one more example of this, and then we'll move on to something else. Sound okay? Okay. And here again, I'm probably going to write down a little bit less work than I did previously. And not write out so many of those statements about like which one I'm doing or whatever. Okay, values for A, H, and K. A is -2. H is +1. K is +4. We'll write our transformation map. X plus 1, -2y plus 4. We'll write down our 3 key points. These points are the same for all absolute value functions. And then we'll plug those into our transformation map to get our new key points. Everybody so far so good? One, two, three, four. 1, 2. We'll plot our 3 points. So 0, 2, 1, 4, and then 2, 2. We'll go back and we'll look at our our inequality symbol to see whether we should be using a solid or dashed line. Because it's the or equal to inequality, I know I'm going to use a solid line. And then we'll go back and look at our inequality symbol to decide if we should be shading above or below. Because it's a greater than symbol, we're going to be shading above. Everybody okay with that? Okay. That's it, guys. That's about as hard as those get. So far, so good? Okay. We have one last skill to talk about today. Sure.
So if they're greater than and less than, shade up when it's greater than, shade down when it's less than.
Yeah, I say above the line and below the line, but yes.
Okay.
So if this was a less than problem, we would have been shading inside the wedge. Okay. The last skill we're going to talk about is modeling absolute value functions. And the idea here is we're going to go from a graph back to an equation, or maybe just info about the graph back to the equation. So we'll just do the explanation of how to do this with a specific example in mind, rather than going through and doing anything in particular. And I'm going to do it this way because we've already kind of established all the tools that we need in order to do this, so there's not much that we need to do differently. So let me just get a good looking graph here. So we're going to write the absolute value function represented by the graph. Here. Okay. So what my answer should look like is something that looks like this, right? This is what we want. So far, so good? Everybody's okay with that idea? In order to write that equation, we need three things, right? We need a value for A, we need a value for H, and we need a value for K. Two of these are quite easy to get. The first tool, the vertex of our graph, is always going to be the coordinates h comma k. So if I look at this graph, my vertex is -1, -5. So that immediately tells me that h is -1 and k is -5. Everybody good with that? So two of the three, easy, 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 easy to get, right? Very little we have to do. All you have to be able to do is identify where the vertex is. So far, so good? Okay. The second thing we're going to need is any other point on our graph. So for example, maybe I notice that that appears to be the point 1, -4. When I trace over from the -4 and then trace back up to the 1, it looks like that's the coordinate of that point right there. Is everybody okay with that? So if I use that other point and the vertex, if I plug all of that in, this other point is an xy, right? So I can plug in for the y. Actually, write that down above it so it's clear. And you guys go back and look what we did there. So y, I'm going to plug in the -4. A is what we're searching for. 1, I'm going to plug in for x. -1, I'm going to plug in for h. And -5, I'm going to plug in for k. Is everybody good with what I did there? Notice you have an equation now with just one unknown in it, just a. So we can just solve this equation for a. So I'll start by adding 5 to both sides. And then I know 1 minus a -1 is really just 2. And the absolute value of 2 is just 2. And usually you write the coefficient in front of the variable. Everybody good there? So if I divide by 2, I get that a is 1/2. So I have my value for a, my value for h, I have my value for k. So if I go and I take those three things and put them together, I have my final answer. Notice that I wrote +1 instead of minus a -1. If you wrote minus a -1, that's certainly fine. But I just wrote it as plus. Does this remind you of anything from Algebra 1? It should remind you a little bit of how you found the y-intercept when you wrote the equation for a line, where you had to find the slope, and then you plugged in any other point and solve for the b, the y-intercept. Very similar feel as to this, right? Should we try one more? Let me generate a graph, and I'll let you guys work on that for a minute or two, and then we'll kind of go through it. So I'm going to give you guys a chance to do one on your own. Does that sound okay? Yes, sir. Okay. You guys see that? Would it be better as black and white? You guys tell me. You can't see it? Would it be better as black and white? Let's try it. It's no big deal. You just tell me what you need, guys. I'm flexible. Oops. It's easy to do. All I'm doing is really cutting and pasting. Is that easier to read? I can make it bigger still. Is that clearer? Okay. Figured I'd see what you guys thought of the color, and we didn't like the color. That's okay. Again, important thing is for you guys to be able to see. I didn't know. I can't really go to the back of the classroom and look at what it looks like, you know what I mean? So I have to wait for you guys sometimes. So take a few minutes here. Try this one out, see if we can do it on our own. We'll go through this in a minute, or 2, or 3, or 4. After a bit here, I'm going to write down the correct answer, so when it looks like people are starting to finish, they can double check to make sure they did things right. And if they made a little boo-boo, they can go back and try to fix it while everyone else is still working. Or as you're working, you can check piece by piece that like, oh yeah, I got the H and K right, or you know, whatever. Okay? Oh, that's embarrassing. Now you'll remember to put that one on silent, huh? It happens, guys. And I'm sure at one point my phone will go off and not be on silent too. You know? You ever been there and had that happen to you guys? Like you're sitting in church or in the middle of the movie theater or something and it goes off and you're like, oh boy, that's my phone, huh? As it's probably been a minute since anybody's been to in-person church or movie theater. Maybe those weren't the best examples, given what's going on in the world, you know. Yes, sir. No, go ahead. You said you want to go to the bathroom?
Yeah.
Yes. Yes, go ahead. Sorry. I thought I said go ahead, and then you looked at me like I answered the wrong thing. I'm like, oh no, did I misunderstand what you were asking to do? Yeah, no problem. So there's our correct answer. Y equals 3 times the absolute value of x plus 2 plus 5. Let's go through and see how I got that. Oh my gosh, guys. How many of you had minus? Yeah, should that be the right, is that the right coordinate? Oh, yay. That's because I am El Dummo, but obviously that's supposed to be positive 5, given where it's at on the y-axis. Oopsie to doopsies. That's my mistake. So if you are goofed up because I wrote something down wrong, justifiable. All right. So 8 should be negative 2. K should be positive 5. Good gravy. Oh, that's weird. I was not expecting it to overwrite it like that. That's okay. So h is negative 2, k is positive 5. So when I plug everything in, negative 1 equals a times negative 4 plus 2 plus 5. So I subtract the 5 over. Negative 4 plus 2 is negative 2, but the absolute value of that is positive 2. And I divide by 2, and there's my negative 3. And there's our final answer. And again, this is a reasonable amount of work to show in terms of a test or quiz question. Like, that's plenty right there that we've done. You wrote down what you found for h and k. You wrote down what you plugged in to find a. And you wrote the final answer. Questions on this one? Okay. Is there any other way we could ask you to do a question like this? Sure, but it doesn't really change much. So let's say we ask you to write the absolute value function with the vertex of negative 2, negative 1, and passes through the point 3, 5. Does this change really anything that we've been doing? No, right? We just don't have a picture to go with it. There's nothing substantially different, though, about this problem. Right away, we can tell the h is negative 2 and the k is negative 1, because we've been given the vertex. And then we can just plug in the x and y. And if we solve for a, we get a is 6/5. So putting it all together, we have this. And again, this is a reasonable amount of work to show for a problem like this. So again, you identified what the h and k were. You showed me what you plugged, or you showed me the equation with everything plugged in, and the solution for a, and then rewrote the final answer, which is kind of the minimum amount of work to show for a problem like this. And that's it for chapter 2. We've talked about all the skills that we're going to talk about for chapter 2. You'll notice on the content library, in addition, now you'll see homework 2, which is 4 graphing problems. Homework 3, which is 4 graphing inequality problems. And homework 4, which is 4 modeling problems, right? 2 of them I give you graphs and 2 of them I give you points. And then I have the test review and test review key posted as well. Wednesday this week is just going to be a general work day, so I'll take questions from you guys on whatever you have on any of these homeworks that you've gotten a chance to work on. And then I'm going to give you the class period to work on things. We'll talk a little bit about the test format that day, but my plan would be to try to do the chapter test on Friday for chapter 2. Does that sound amenable to all you guys? So hopefully with the whole class period on Wednesday, I know that was a lot of homework assignments, but it's not that many problems in total. I think it's just 12 total problems. And then the chapter review, you should have enough time to kind of get a good chunk of that taken care of, even if you hadn't got a chance to start anything beforehand, which you should. And all that stuff is up on PowerSchool. Okay? Sound fair or fair enough? Okay, cool. And we're done for today, so you can get started on homeworks or working on something else if you have any last minute things to catch up on. We have what, like